All right, we've learned two methods for volume. Now let's do a little bring it home summary here. So we've got both the disc and washer method and the shell method, but we approach them a little bit differently, right? So I'm going to squeeze this in up here. Let's talk about this top part real quick. When you have integration with respect to the x is what they're saying. If I have, for this washer method, if I'm looking at the same axis, so I have the x-axis and dx, that is your disc and washer method. I have a dx, my variable is in terms of x, my bounds are in terms of x. Same variable as your axis and your differential. All right, all of that's the same. I'm going about this x-axis. All right, if I am going to use the shell method, that is the other axis. In this instance, the y-axis. If my differential here is in dx, everything has to be in dx, but I'm going around that other axis. All right? That is the key, around the y-axis. However, my variables are all in terms of x. I have my radius is in x. I have my functions in x. My bounds are in x. Everything else, I'm just going around the other axis. Shell method goes around the other axis. All right, that's the kicker. If you have the washer method, the disc method, those are the same axis and same differential. All right? Okay, if you can set that up, that's what you want. Same thing that I'm happening here. If I'm going around the y-axis, my differential for the disc washer method that I have is going to be around that same axis as my differential. Same concept applies. And the disc washer method we know is that pi r squared, because that's my circle, where my shell method is 2 pi r h every single time. All right, so disc washer is pi r squared, and my shell method is that 2 pi r h. And again, if I'm going around the y-axis, that means my differential is also the y. That's what I'm looking at. Y-axis, my differential, that should be an n. Differential is also going to be dy. It is the same. If I'm looking at my shell, whatever it is sitting on, that is the axis I have. Here is the x-axis. I am sitting on the y, so that tells me that my differential is going to be dy, even though I'm revolving around the other axis, right? That is my shell method. My disc washer is the same. My shell method is the opposite differential that goes with that axis. Again, everything is based on this differential. My variables are in terms of y. My radius here is in terms of y. My bounds are in terms of y. Whatever your differential is, that is what your whole function is set up in terms of. All right? Okay, that's the key. Disc washer method, same axis, same differential. Shell method, revolving around the x-axis, your differential is in the other variable. Okay, good. Now let's look into that a little bit more here.